Hello students, welcome to the next class. In this particular program or in this particular session, we are going to perform certain operations on array. Those are basic operations such as how to reverse an array, how to check whether particular element is a prime number or not, or an Armstrong number or not. So all those basic operations we are going to perform in this session. So the first part will be how to reverse an array, and the second part will be how to look each element and check each element whether that element is a prime number or not. So starting from very basic, that is start from hash include stdio.h, that is standard input and output library, and hash include stdlib.h, standard library. Inside main function, we are going to declare an integer type array int a of size, let's say 10. We are going to need a variable for iteration of the loop, that is I variable, temporary variable, and another variable j variable. Again, it will be used to reverse an array. After this, you'll print a message on the screen, printf enter the elements in the array. Enter the elements in the array. After that, you will run a loop for I equals to 0, I is less than 10. At every iteration, I will increase by 1. So I plus plus. Inside this body of loop, you will scan each and every element. Percentage d is the format specifier for integer, and address of a of i. Address of a of I. Now after this, the body of loop is closed. Now you have the array. The array is successfully inputted to the program. Now what you have to do is you need to reverse an array. For example, reversing an array means you need to actually reverse the array. That means you need to swap the elements. Like first element will be swapped to the last element will swap with the first element, like that. Swapping means actually reversing the element's memory location. So basically you are not reversing the memory location, you are just changing the elements, like such as the element is stored at 0th index and the size of array is 10. So 0th index element will swap with the 9th index element. First index element will swap with the 8th index element, like that. So reversing array means you need to swap the elements. And reversing does not means that you will run a loop starting from 9 to 0, I minus. That is a wrong case. So how you will reverse that? Let's say if the size is 10, that means I will start from 0. The first index will be 0th index. The last index will be the 9th index. J will be 9. What you need to do is you need to swap the elements. So how you will swap? So basically what you will do, you will take a variable temp equals to a of I. That means the starting index element will go and store at temporary variable. Now a of I equals to a of j. That means when I is 0 and j is 9, so 0th index element will swap with the 9th index element. So a of I equals to a of j, and a of j equals to 10, just like that. And of course you are increasing the I value because you need to move forward. So I plus plus and j minus minus and j minus minus. You are moving from left to right, from I variable with I variable, and moving right to left with j variable. So you need to repeat this process till in a while loop. You need to repeat this process in a while loop until the condition is while I is less than j. While I is less than j, you need to repeat this condition. You need to repeat this section of code. Give a tab space. Now you are inside the loop. you are inside a loop, and this loop is closed over here. Now after doing this, the array is reversed. That means now printf the array after performing the reverse operation looks like this. The array after performing reverse operation looks like this. So again you will run a loop for I equals to 0, I is less than 10, I plus plus at every iteration. Inside this for loop, what you have to do is you have to print the values of I, a of I, printf, percentage %d is the format specifier for integer, and a of I. So now you have reversed the array, and you have also printed on the output screen the reversed array. Simply run this program, save it, and let's run it. So for running it, open it in terminal. The file name is what is the file name? Yeah, this is arrrop, array operations.c. So open in terminal. GCC file name is arrrop.c -o arop. So okay, there is an error in line number 20. Okay, missed the semicolon. Again clear it, go to the files, again open the terminal. GCC file name is arrrop.c -o arop. /arrop, enter the elements in the array. So let's say elements are 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. So this is the array, and you can check the array is in increasing order, or the element 10 is at 0th index and element 100 is at the last index. So when I press the enter, the array will be reversed. So the array after performing the reverse operation looks like this. So it is looking like this because we haven't given the space after this format specifier. So let's give a space, run it again. So GCC file name is arrrop.c -o arop. /arrop, and now enter the array 14, 15, 48, 78, 52, 65, 42, 49, 83, and 100. So array after performing the reverse operation looks like this. Again it is reversed. So let's save it and run it again. Control S, open in terminal. Open in terminal. Now GCC file name is arrrop.c -o arop. /arrop. Now 14, 15, 18, 17, 19, 52, 32, 78, 455, 145. So now you can see the array is reversed. The element 14 was at the starting position. Now 14 has moved to the last position, and 145 was at the last location. Now 145 is in the starting location. So this is how you reverse an array. So this is the program to reverse an array using while loop. Now second program is based on checking an element is a prime number or not. If it is a prime number, print it. So the program is, we have an array and there are certain elements inside the array, and what you need to do is you need to check each and every element, that is that element a prime number. If that element is a prime number, that means you need to print that element. So the second phase of the program is that. So we should remove this all of this. Now we need to have another variable, count variable. Count is 0 in the starting position. So now we have the array and we need to perform the operation for the prime number. So again, to perform the operation of prime number, what we need to have is a for loop. Again, for will run from I equals to 0 and I is less than 10 and I plus plus at every iteration. Inside this for loop, what we have to do is we need to check by dividing each element with j. For example, the second loop of j will run from, for j equals to 0, or let's say for j equals to 1, because divide by 0 is an error. For j equals to 1, j will go till the element's value j is less than equal to a of I and j plus plus. Inside this loop, we're going to divide if a of I mod 2, a of I mod not 2 but mod j, mod 2 was for the prime number, a of I mod j equals to 0. If it is true, then we are going to increase the value of count plus plus, and after that we are checking. After performing this section of code, we are checking whether the value of count is 2 or not. If it is 2, simply print that element. So we'll check if count equals to 2. That means simply print that, printf %d a of I, because we are printing that particular element which is a prime number, because count will become 2 only when the element is divided by 1 and itself. So when the element is divided by 1 and itself, it is a prime number, so we are printing that particular element. And after printing, we need to reset the value of count again to 0. Count equals to 0, because it will go and add on in the count same variable, because we are not resetting it. If we are not resetting the count value, what will happen? These all divisions will continuously added in the same variable count, this count, because if it is not 0, then count 2, 3, 4, it will go on increasing. So we need to set count equals to 0 again. Give a backspace. Simply the program is over here, so save it and let's run it. What happens? Go to the files, open terminal, clear it. GCC file name is arrop.c -o arop /arop. Enter the elements in the array. So now we'll enter the elements very carefully. Like some of those will be prime numbers, some of those will be a non-prime number. So let's say 12, 15, 70, 5, 17, 18, 23, 25, 29, 48. So the prime numbers are 5, 7, 23 and 29. So we can also modify this program in a certain way that we can give a statement. The prime numbers are as follows. So let's say we're giving a statement, printf the prime numbers in the array are as follows. Close this. And what happens if there are 0 prime numbers? What happens then? So for that, we are taking a variable flag equals to 1, and in the beginning we are setting flag equals to 0. If there is not a single prime number in the array, what happens? We'll check outside this loop. if flag is same as the before. If flag equals to 0, that means the flag's value has not been changed, and in that case we'll print a message, printf there are no prime numbers in the array. There are no prime numbers in the array. Simply close it and let's run it. Save it and run it. Go to the files, open it in terminal again. GCC file name is arrop.c -o arrop. Now enter the elements. Let's say in this time we are entering the elements, those elements are non-prime number. Let's say 100, 200, 400, 500, 14, 18, 74, 28, 68, 98. So the prime numbers in the array are as follows. So there are no prime numbers in the array. So this is how you make the program to check for each element inside the array whether that element is a prime number or not. So for now it is enough, and in the next class we will continue on array. Thank you very much. Have a good day.